Hello and welcome to IB Economics. Today we are looking at the topic public goods and a few other subtopics as well, including common access resources and government responses to threats to sustainability. 1.13 Public Goods. I hope you learned something. Right, public goods. We have a definition here. The key points are non-rivalrous and non-excludable.
A public good is an item whose consumption is determined by society, not individual consumers. Examples include economic statistics, law enforcement, national defense, parks, sewer systems, and some radio and television broadcasts. Public goods are usually financed by taxes because they're created for the benefit of everyone. A public goods consumption does not reduce its availability to others. Economists divide public goods into non-rivalrous and non-excludable categories. A fireworks show is non-excludable because the cost to keep those who won't pay to watch it can be prohibitive, but it also demonstrates the free rider problem. The free rider problem states that a rational person will not contribute to the maintenance or availability of a public good if they do not need to contribute to maintain its benefit. A non-rivalrous public good may be consumed simultaneously, but many without diminishing returns. In our fireworks show example, if the show charged an entrance fee but was still visible to people who chose not to attend, the free riders watching is non-rivalrous. The show's value isn't diminished when they choose to watch it from afar.
Okay, because these goods are non-rivalrous and non-excludable, they are not going to be supplied in the free market. Market failure. Okay, so we have the two key concepts here within public goods that you need to get across to your examiners: non-rivalrous, non-excludable. So non-rivalrous, when the consumption of a good or service by an individual does not reduce the availability of the good for others in the market. Examples here are shipping and lighthouses. These are considered non-rivalrous because the use of a lighthouse by one ship doesn't make any less available of that to other ships. Non-excludable, so once this good or service is supplied, then it's impossible to prevent individuals from consuming or benefiting from it, and we saw the example in the video there of the fireworks. Other examples would include national defence. That national defence confers the benefit of protection to all in society, and not just for the select few who would be willing to pay for it. Examples: police forces, non-toll roads, national parks and recreation areas, national defence, fire services, flood control, and basic research and development are all good examples.
The world nearly ended on September 29, 2004. That's when the asteroid Tutatis narrowly missed the planet. An asteroid wiped out the dinosaurs, and it could end humanity as well. In fact, your probability of dying from an asteroid strike is about the same as your probability of dying from an airplane crash. Now, the probability that a big asteroid will hit the planet is very low, but if one does hit, it's probably going to kill everyone. So the risk is actually much higher than it appears. So could the invisible hand protect us from asteroids? Sadly, no. A good like asteroid protection has some unusual properties that challenge markets. If you pay for a pair of jeans, for example, then you get the exclusive use of those jeans. And if you don't pay, you are excluded from using those jeans. That's pretty obvious. But asteroid protection is different. Asteroid protection is non-excludable. Even people who don't pay will be protected. So think about whether you want to pay for asteroid protection. Your payment is probably not going to make a difference between a successful and an unsuccessful defense. So there are really only two cases to consider. Either enough other people pay so that you are protected, or enough other people don't pay so that you aren't protected.
Bad deal, dude.
Either way, whether you pay or not doesn't determine whether you get the protection or not. But paying does determine whether you get the genes. Faced with this logic, many people may decide to buy the genes and try to free ride on the kindness of others who pay for asteroid protection. But if lots of people free ride, then no one is protected, even if asteroids threaten everyone. Asteroid protection is an example of what economists call a public good. A good that is non-excludable and also non-rival, meaning that it doesn't cost more to protect more people. We will be looking at more non-excludable, non-rival goods, the challenges these goods give to markets, and the options for providing these goods in the next video. If you want to test yourself,
A good example there, and well explained in that video. The free rider problem.
Free rider. It sounds like an ex-hippie motorcycle group, but really, actually, it's an important economic concept that deals with public goods. A free rider is someone who receives the benefit from a good or service without paying for it. And this usually pops up with the issue of public goods. Because remember, public goods are non-rivalrous in consumption and not subject to exclusion. So the problem is you can get these free riders, these people who use a good without really paying for it. Right, so think about things like defense, think about things like weather warning systems, right, that what happens is one person consumes it, doesn't keep anybody else from consuming it, and you can't exclude those people who don't pay for it from consuming it. So the free rider problem is a huge issue with these public goods. If you have lots of free riders, what eventually you're going to wind up with are all these people who are using the public good without really paying for it. That's usually why the government has got to step in and provide a lot of these public goods, because it's the only way to get around the free rider problem. Everyone, meaning all the taxpayers, meaning society, has to pay for the provision of our public goods to get around the free rider problem.
Okay, so without consumers paying for this good, because it's non-excludable and it's non-rivalrous, it's not going to deplete, there's no profit to be made, and in the free market such goods are not supplied. And this is how it relates to market failure. The free market won't provide these essential goods and services. Common access resources.
In the final video in this section, we turn to common resources. We'll cover the tragedy of the commons and talk about some possible solutions. Common resources are those that are non-excludable but rival. Unlike public goods, common resources get depleted as more people use them. Tuna in the ocean are an example of a common resource. The tuna are non-excludable because there are no property rights to fish in the ocean. No one can legally be prevented or excluded from fishing for tuna, at least outside of a nation's territorial waters. Tuna, however, are rival. One more tuna caught leaves one less tuna for everyone else. Non-excludable but rival resources often lead to a tragedy of the commons, a destruction of the common resource. In the case of tuna, that means the collapse of the fishing stock. More generally, the tragedy of the commons is the tendency of any resource that is unowned, and hence non-excludable, to be overused and under-maintained. In the case of tuna, it's the stock of fish that's the common resource, and the stock is being rapidly depleted. Since 1960, the tuna catch has decreased by 75%. Atlantic bluefin tuna especially are becoming endangered. Now, no one really wants this. Tuna consumers don't want it, and neither do the tuna fishermen, whose way of life is under threat. So why is it happening? You might think the answer is obvious. Tuna is delicious. The demand for sushi is up. But that can't be the whole story. Chicken is also delicious, but chickens are in no danger of going extinct. So why the difference? Well, let's compare the incentives of Frank Perdue, the famous chicken entrepreneur, with the incentives of a tuna fisherman. If Frank Perdue harvests too many chickens today, he won't have any left to sell tomorrow. so he'll be out of business. Purdue has an incentive to preserve the chicken stock, to maintain it, so that he can continue in business into the far future. When Purdue sells less today, that's costly, but he gets the benefit of selling more tomorrow. On the other hand, consider a tuna fisherman. He knows that the stock of tuna is going extinct, but does he have an incentive to conserve? No. If he conserves and fishes less today, that doesn't leave more tuna for him tomorrow. It leaves more tuna for another fisherman to catch today. The tuna fisherman has no incentive to conserve because he doesn't own the stock of fish the way Frank Purdue owns the stock of chickens. So the tuna fisherman doesn't have an incentive to maintain the stock. And as a result, we get the tragedy of the commons. The tuna stock collapses. There's no more sushi and no more jobs for fishermen. That's a tragedy. Here's another more prosaic example. Do you have roommates? Take a look at your kitchen. That's the tragedy of the commons. There are many other examples, often from the field of the environment. The 19th century slaughter of open-range buffalo, deforestation today in the Sahel region of Africa, the hunting of elephants and rhinos to near extinction. In each of these cases, no one owned or owns the resource in question. No one could be excluded from hunting the buffalo, cutting down the tree, or killing the elephant. Thus we get the overuse and under-maintenance of the common resource. Are there any solutions to the tragedy of the commons? Let's look at three approaches: command and control, cultural norms, and creating property rights where before there were none. Command and control are rules and regulations that are often used to try to limit or avoid the tragedy. But these methods are also often inefficient and ineffective. Just to give a few examples, when fishing stocks begin to collapse, the number of fishing boats is often limited, or the number of fishing days is limited. To try to save the Alaskan king crab, for example, the government imposed shorter and shorter seasons, until at one point it was legal to fish for these crabs on only 4 days in an entire year. The problem is that when the number of boats or the season is limited, the fishermen simply build bigger and better boats, boats stuffed with all kinds of fancy equipment, so that they can quickly find and harvest the fish. As a result, these regulations get more and more complex over time, with limits on fishing boat size, horsepower, equipment, and so forth. Sometimes these limits slow the tragedy, but they usually don't prevent the tragedy. What about cultural norms? Can they prevent the tragedy of the commons? Elinor Ostrom, the 2009 winner of the Nobel Prize in Economics, studied common resources throughout the world, and she discovered that the tragedy of the commons is not inevitable. What Ostrom found is that under certain conditions, norms can evolve, so that people who overfish or overgraze, they're socially disapproved, and those who contribute to the common resource, they're honored. Quite sophisticated procedures for managing common resources can develop, especially when groups are relatively stable and small. These procedures do take time to develop. It's possible, therefore, to avoid the tragedy, but it isn't easy. Try to see if you can come to an agreement with your roommates to keep the kitchen clean. Let's see how long that lasts. What about making a common resource excludable? By creating property rights over common resources, it's possible to have a common resource behave more like a private good. New Zealand, for example, pioneered an innovative solution to the tragedy of the commons. They created tradable allowances in fish, much as we discussed in earlier videos about tradable allowances in pollution. Just like in that example, property rights were created where before there were none. New Zealand used what are called individual transferable quotas, or ITQs. An ITQ gives a property right to a certain tonnage of fish. The sum of the ITQs is the total allowable catch per year. The ITQs can be bought and sold. Now, the nice thing about these ITQs is that there's no restriction on boats or on equipment. So there's no wasted resources on capital stuffing, on making the equipment really more, quote, efficient than it really has to be. The ITQ systems have really been very successful. Let's take a look. Here's a graph showing the total fishable catch in New Zealand. Once the ITQ system began in 1986, the total catch increased dramatically. Now that may seem paradoxical. After all, the quotas reduce the amount of fish that each fisherman is allowed to catch. So how can the total increase? This is actually just the tragedy of the commons in reverse. In the tragedy of the commons, every fisherman tries to catch as much as possible. But the end result is that none of them do. The fishing stock is driven to extinction. With the ITQ system, a fisherman owns a right to a certain amount of fish year after year. Much like Frank Perdue, the fisherman now wants to make sure that he preserves the value of his property over the long run. He doesn't want to overfish and destroy the fishery. He also has an incentive to make sure that other fishermen are obeying the ITQs. Over time, this allows the fishing stock to increase, to recover, and that allows the quotas to increase as well. So under the right system, we can turn the tragedy of the commons around, and we can create a happy solution. Unfortunately, it's not always possible to create property rights. Southern bluefin tuna, for example, they don't stick around the territorial waters of a particular nation. They often migrate thousands of miles throughout the Pacific. Creating property rights in the tuna would require a multi-country agreement, and that's difficult to enforce. As we know from the Coase theorem, the more parties required to make an agreement, the greater the transactions cost, and the less likely an agreement is to actually happen. To see how far we have to go, let's just remember, most governments subsidize fishing. We've got a long way, therefore, to solve these problems. In short, many of the world's problems, they arise when property rights are not possible, are not protected, or are not really implemented. Thanks.
If you want to test yourself, click Practice Questions.
Okay, let's have a look at these common access resources in a little bit more detail. So there's a lack of a pricing mechanism for common access resources, and this means that these goods can be overused, depleted, degraded over time as a result of the activities of producers and consumers who don't pay for the resources that they use. And this all poses a big threat to the sustainability of these resources. Now, for a resource to be sustainable, it must be able to be maintained at a certain rate or level over time. They're a little bit like public goods in that they're non-excludable, and they're a little bit like private goods in that they are rivalrous. For self-interested individuals, common access resources immediately lead to the problem of these resources being overused, depleted, and or degraded. Right, overuse. An example here, California has a water shortage problem. Farmers have limited access to stores of water from their underground aquifers. A farmer drawing a litre of water from a private well on her land means that 1 litre of water is now not available to another farmer drawing water from a well on his land. It's in the best interest of each farmer to take as much water as possible, to grow as many crops as possible, and make as much profit as possible. This scarce water reserves are misallocated. They're overused. Each farmer now has to drill ever deeper and more costly water wells to keep irrigating their crops. Depletion. The world is running out of fish. Fish stocks are being severely depleted because any individual firm with access to an ocean-going fishing vessel can fish the open seas. just as we saw with the bluefin example in the video. However, fish stocks are limited, and once a fish is caught, it is then not available to another consumer to benefit or producer to profit from. Overfishing results as each fisherman or fishing company seeks to maximize their own profit, knowing that if they don't harvest the fish, someone else is going to. Degradation. China and India are infamous for the amount of air pollution they produce. In a free market, factories can't be excluded from polluting the air, and doing so is less expensive and therefore more profitable than adopting cleaner technologies. Coal-fired power stations produce the lowest cost electricity and are the most polluting. In a free market, power stations that turn coal into electricity while belching out polluting emissions into the atmosphere for everyone else to breathe are the most profitable. The end result being air in these countries are degraded for everyone. And fossil fuels and sustainability. When we burn fuels such as oil, coal and gas to power transport, provide electricity, we are emitting atmospheric greenhouse gases. And this is detrimental to the environment. Climate change and air pollution are the negative externalities or the external costs caused by such pollution. When the planet warms, wetter areas tend to become wetter and dry places tend to become drier. Droughts and floods affect producers, for example farmers, and consumers, such as homeowners. Rising sea levels will force future generations to incur costs to pay for infrastructure, such as flood protection measures, and thus the third parties affected by climate change are going to be found not today in this generation, but in our future generations. So in the market for coal-fired electricity, we have in the free market price equilibrium and quantity equilibrium, but that's nowhere near the marginal social cost. Price should be higher, quantity produced and consumed should be lower to the allocatively efficient level. Right, so that's the external cost and the deadweight loss in this market. The social costs of steel production are greater than the private costs. In the free market, the price of coal is too low, PE instead of P star, and the output of coal is too high, QE instead of Q star. So therefore, between Q star and QE, marginal social cost is greater than the marginal social benefit. The marginal social cost is less than the private benefit of coal consumption because of the negative externalities associated with the production of the good. The yellow triangle showing the deadweight loss, that welfare loss to society. Right, the additional benefit of consuming one more unit of good or service is a marginal private benefit. The additional external benefit, obtained or harm caused by consuming an extra unit of a good or service is a marginal external benefit. And we know marginal social benefit equals a marginal private benefit plus those spillover costs, that marginal external benefit. So negative externalities of consumption result in the MSB curve being below and to the left of the marginal private benefit curve. We're looking at petrol consumption here in this particular model. It negatively affects others. The benefit gained by the private consumer is greater than the benefit obtained by society as a whole. Therefore, MSB is less than MPB. The allocatively efficient point of consumption is Q star, and Q star is quantitatively less than QE. In the free market, QE is achieved because the price of petrol is too low, and at that low price, too much petrol is going to be consumed. The yellow triangle showing us the total welfare loss to society. Right, the use of fossil fuels is going to lead to negative externalities in a range of different markets and has two implications for sustainability. The massive use of fossil fuels today is going to limit fossil fuel availability for the future generations. So their ability will be impacted. They will be less likely to be able to satisfy their needs and wants at a future point in time. And the second one, the external spillover costs generated by climate change and caused by massive fossil fuel consumption now are going to be paid for by our future generations. This is going to reduce their income and generate opportunity costs. For example, $1 spent on flood defence is $1 less that is spent on health and education services. So how do we correct for these negative externalities of production? We've had a look at this before. Let's quickly go over it again. We have legislation. Governments can enact laws and regulations so that forcing firms to reduce or prevent the spillover costs associated with negative production externality. If firms are polluting, then governments may ban the dumping of toxic waste and materials into the environment, such as factories using rivers to dump their wastes. Right, legislation is going to increase the cost of production to firms. They're going to have to now pay more to reduce their emissions, their polluting emissions. They're going to have to invest in better and more efficient technology, capital equipment, and that adds to the cost of production to firms. Governments can regulate, legislate production at a pollution limit, and this will reduce the quantity of the good or service being produced, creating that negative externality of production. It's going to reduce that quantity being produced and therefore consumed. So a pollution limit is imposed, so that's legislation or regulation, restricting production to the efficient quantity, and that allocatively efficient market equilibrium is then achieved. The market price becomes equal to the marginal private benefit, MPB, and marginal social cost, MSC. We can tax it. There are pollution taxes out there, and these seek an efficient outcome by making a polluter pay the marginal external cost of their pollution. Governments can either impose a tax on each unit of output produced by the firm, or they could tax per unit of pollutant that is being emitted. And an example there would be a carbon tax. So free market, price is too low, quantity too high. Marginal social cost is less than the marginal private cost. We want less of it. Here's the efficient market equilibrium, a higher price and less quantity being produced and consumed. The pollution tax comes in, tax per unit, and that shifts the production of this good to the MSC, and the government will raise tax revenue as a result. So by charging or taxing the producer at the rate equal to the marginal external cost, the marginal social cost curve becomes a market supply curve. That tax results in supply decreasing, shifting up and to the left from S equals marginal private cost to S equals marginal social cost, and marginal social cost being the MPC plus the tax. This causes the market price to rise, and the quantity produced decreases to the efficient quantity, the allocatively efficient quantity, and the government has the added bonus of collecting tax revenue by the amount shown here by that yellow triangle. Triangle, rectangle. Essential statement, this is what you want to get across to your IB examiner. A tax on pollution makes a polluter pay, and this polluter pay principle makes that externality become internalized. The costs that were forced onto and paid by third parties are now paid by the producers and consumers who are producing and consuming in this market. We can use our tradable permits. Market or pollution permits, also called cap and trade.
When gases like sulfur dioxide and nitrogen oxide are emitted into the atmosphere, they react with water, oxygen, and other chemicals to form sulfuric and nitric acid. And when these acids precipitate, we get acid rain. Acid rain can kill trees, plants, and fish, as well as erode automobile paint, buildings, and stone. The Clean Air Act amendments of 1990 introduced a novel way to combat acid rain: tradable permits. Wow. Here's how they work. Let's consider two power plants or factories that are polluters. They emit this much polluting gas. The government could control pollution by just commanding that all factories install certain technologies, like scrubbers. Using this command and control method, suppose that pollution would be reduced to this. Okay, but now imagine that one of the plants can reduce pollution at a lower cost than the other. Perhaps it's newer, or it uses a different type of coal, or maybe there is some other technology for reducing pollution that the government didn't consider, or perhaps the product produced in one of these factories has a less polluting substitute that we can easily switch to. Ideally, we want to reduce pollution here, where reducing pollution has a low cost, and less here, where reducing pollution has a high cost. If we do this, we can reduce pollution by exactly the same amount as before, but we can do it while wasting fewer other resources. Great. But wait. Unfortunately, the government doesn't know which plant is the low-cost plant. Remember, there are lots of ways of reducing pollution, lots of substitutes, and lots of substitutes for substitutes. No one person knows all the trade-offs. Information is dispersed. So how can we draw on this dispersed information and harness the energy of entrepreneurs to discover the best ways to reduce pollution? Instead of commanding how to reduce pollution, suppose the government issues pollution permits, rights to emit pollution. One permit gives you the right to emit, say, 1 ton of polluting gases. Pollution permits don't sound very environmentally friendly, but the government only issues a limited number of permits, and that equals the same total reduced pollution as under command and control. So in the end, pollution reduction is the same. By allowing the permits to be bought and sold, the profit-seeking self-interest of power plant owners is harnessed for the social good. The owner of the power plant with the low cost of reducing pollution thinks, I don't have to use my permits. I can reduce pollution at my plant for less money than I can get by selling my unused permits and make a tidy profit.
Oh, yeah.
Meanwhile, the power plant owner with the high costs wants to buy permits and is willing to pay a lot because it's cheaper to buy permits than reduce pollution at high cost. So, the power plant that can cheaply reduce pollution sells permits, and the power plant where it's expensive to reduce pollution buys permits. Both firms increase their profit. In this way, the invisible hand of the market gets us to the ideal solution. We reduce pollution more here, where reducing pollution is cheap, and less here, where reducing pollution is expensive. The total amount of pollution, however, is reduced just as much as with command and control, but at a lower cost. In fact, the tradable permit approach worked so well, it reduced air pollution at a much lower cost than any expert had anticipated. Why should we care about the cost of reducing pollution? Spending less on reducing pollution means that we have more to spend on other goods. But also, don't forget the law of demand. The lower price of pollution reduction, the more pollution we want to reduce. Tradable permits uses the invisible hand of the market to discover the lowest cost way of reducing pollution, and that's good for everyone. If you want to test yourself, click Practice Question.
Let's have a look at these tradable permits. Let's model them and have a look at them in a bit more detail. We're looking at carbon dioxide here, CO2 permits. The demand and the quantity of CO2 that is permitted to be released into the atmosphere during production. The supply of these permits are perfectly elastic and fixed at this quantity by the government. Industry cannot produce more CO2 than this amount here. So this is determined by the government, distributed to firms. Firms can't produce more pollution than the permits they have allow them to. The demand for such permits is going to determine the market price. As the economy grows, the demand for such permits may increase, and if this happens, so too will the price. Firms will have an incentive to reduce their emissions to reduce the cost of production and or sell permits to other less efficient firms to earn additional revenues. And over time, the amounts of permits that are issued will become ever less, hopefully. So over time, as the government reduces the supply of such permits, reducing the level of pollution being emitted by firms operating in the economy, and further reducing the external costs imposed by this on third parties. Governments are going to usually purchase its own permits circulating in the economy, and as they do this, they're going to reduce the supply available to firms. As supply is reduced, the price of these permits are going to increase, providing firms with more and more incentive to reduce their own emissions, reducing their cost of production. To become more profitable, firms can adopt new technologies and or substitute in less polluting inputs into their production processes. Regulation. A government can regulate to correct the negative externality of consumption. We know that cigarettes can only be sold to those 18 years and over. We can't smoke cigarettes in workplaces, cafes, bars, restaurants, and this reduces the demand for cigarettes. Demand curve will decrease from D1 equals the marginal private benefit until it overlaps with D2, which is the marginal social benefit, which is the socially desirable level of demand where the externality has been eliminated. We say that's internalizing the externality. As demand decreases, the important effect is that QE decreases to Q star, and unimportantly, price reduces from PE to P star as producers lower their prices to reduce the surplus, that excess supply of the demerit good. So we're not worried about the price decreasing. With an effective regulation, the quantity is going to reduce, and that's exactly what we want. Reducing to the efficient market equilibrium where demand is equal to the marginal social benefit. Advertisements may be able to correct an NEC, and this is done by just the same method, reducing demand, reducing the demand for the good. So anti-gambling, anti-alcohol and anti-smoking advertisements. Governments quite often run these campaigns in many countries. This reduces the demand for such goods and reduces the quantity being consumed in the market. That external cost is internalized to the efficient market equilibrium. Unimportantly, the price decreases. Importantly, the quantity consumed decreases. Your essential statement to get across to your examiners: the allocatively efficient point of consumption is where MSB equals MPC. One way that negative externalities of consumption can be internalized is by decreasing demand for the product and shifting MPB left to where it overlaps the MSB curve. This can be achieved through advertising or government regulation. Excise taxes. An excise tax is an indirect tax. By charging or taxing the producer at a rate equal to the marginal external cost, the marginal social cost curve becomes a market supply curve. Market price rises, quantity produced decreases to the efficient quantity, and the government collects tax revenue of the amount shown here in the yellow triangle. Essential statement: the other way to internalize a negative externality of consumption is to place an indirect excise tax on the good or service. This will not decrease the demand for the demerit good. However, the higher price will decrease the quantity demanded for the demerit good to a quantity equivalent to that achieved when MSB equals MPC. The excise tax shifts the MSC left to a point where it intersects with MPB directly in line with the efficient market equilibrium. Positive externalities of production. A government can provide the good or service that is creating the positive externality of production. A good example of this is governments will often fund and engage in research and development programs across many diverse areas such as food and agricultural science, new technologies, defence, pharmaceuticals and medicine. Governments are going to directly provide education and training for workers, schools, tertiary institutions such as our universities and polytechnics, and back-to-work courses for the unemployed. And essentially this increases the supply of the positive externality producing good to a point where supply becomes the MSC. Those spillover benefits, direct provision of the good generating positive externality production increases the supply of the good, shifts the supply curve, MPC right, towards the MSC curve. At MSC, the socially optimal quantity of the good or service is produced at Q star, and the price of that good will decrease from the free market price, PE, to P star. The government can subsidise a good or service producing these positive externalities of production. So we know a subsidy is a sum of money granted by the state to help an industry or business keep the price of a good or service lower than the market can usually supply it. Supply increases, the lower cost of production makes supplying the good or service relatively more profitable. That subsidy decreases the cost of production to firms, and any subsidies are going to increase supply and shift the supply curve to the right. The use of a targeted subsidy may be able to correct an allocatively inefficiency by correcting a market failure. Internalising those spillover benefits going to cost the government some money. And to fully correct for the market failure caused by positive externality of production, the government's going to pay the firm a per unit subsidy that's equal to the value of the external benefit. The marginal private cost curve shifts right until it overlaps with the MSC curve. Paying a subsidy to firms producing the good generating the positive externality production increases the supply of the good. Therefore, we have that shift of the supply curve, right? And that shift is towards the MSC curve. At MSC, the socially optimum quantity of the good or service is produced at Q star. That's an increase from the market equilibrium quantity, and the price will decrease from the market equilibrium quantity there, PE, to P star, the optimum or allocatively efficient level. Here's your essential statement. Both direct provision of a good and paying a per unit subsidy have the same market outcomes. That's because correcting a positive externality of production requires that the MPC curve shift right towards the MSC curve. To achieve the allocatively efficient outcome in the market, the quantity produced and consumed in the market must increase from that free market quantity, QE, to Q star with that government intervention, and the price needs to fall from the free market price, PE, to the allocatively efficient P star. Legislation can also correct for a positive externality of consumption. So greater consumption of merit goods can be achieved by governments if they enact laws that compel individuals to consume them. All developed countries have compulsory schooling. Children and teenagers must attend school on a regular basis up until their late teens. And therefore we have an increase in demand for education. The same is true in some countries with their vaccination programs. It's a requirement to get your children vaccinated to receive benefits and subsidies and educate your children. This increases demand for the good. There, from the D1 equals a marginal private benefit to D2 equals a marginal social benefit. So direct provision of the good creates the same sort of effect as legislating for the good as well. So it increases demand. Advertising can work to inform people about the effects of these goods that they consume that create positive externalities of consumption. So vaccination advertising campaigns can be found in many countries around the world. The objective is to increase consumer demand for such vaccinations to the efficient market equilibrium. Because in the free market, these goods are underconsumed. Advertising increases demand. Demand curve, MPB, shifts right, ideally to the point where it overlaps with the MSB curve, and that allocatively efficient quantity, Q star, is consumed at P star. Government can provide the good that creates a positive externality of consumption. So government's funding K-12 education, healthcare services and hospitals, vaccination programs. The benefits of such merit goods are so great that it's generally accepted that such important goods and services can't be left to the free market. All such activities are paid for through government funding that comes from taxes. So, direct provision of a good generating the positive external production increases the supply of the good. That's shifting the supply curve, MPC right, towards the MSC curve. At MSC, the social optimum quantity of the good or services produced at Q star, and the price will decrease from that free market equilibrium price, PE, to P star. Okay, let's have a look at this from an international perspective. International cooperation agreements are often necessary to correct for market failure. A good example here is global warming, climate change, and greenhouse gas emissions. No one country can have much of an effect on reducing the external costs of climate change because these occur globally. International agreements such as the Paris Agreement are needed. Right, signatories and parties to the Paris Agreement. This is an agreement within the United Nations Framework Convention on Climate Change, dealing with greenhouse gases emissions mitigation, adaptation and finance starting in the year 2020. The language of the agreement was negotiated by representatives of 195 countries in Paris and adopted by consensus in 2015. As of November 2016, 193 members have signed the treaty, 105 of which have ratified it. After the EU ratified the agreement on October 2016, there were enough countries that had ratified the agreement that produced enough of the world's greenhouse gases for the agreement to enter into force.